All right, good afternoon, grade nines. I hope that you guys are all doing well and that your Tuesday has treated you well so far. Guys, we're back again now for week 15 worth of our lessons, and we're going to get started quite soon. Just as per usual, guys, I want to give everyone a chance to join us, and then we will get started with today's work. Okay. So guys, I'd really appreciate it if you could please put your names into the comment box for me so that I can see who's here today. It's not for any form of register keeping, it's just so that I can get familiar with the students that attend more often. Number two, please make sure that you have a way of taking notes. You need to make sure that you have a calculator as well, please. All right, that's going to be standard for every week as it is already. So make sure you have everything you need for taking notes. And then, guys, please remember that you're welcome to ask any questions if there's anything that's bothering you. But we are going to get started quite shortly. Guys, we have been talking about the world of measurement as of late, and there were quite a lot of questions from students about circles. Okay, now what I want to do is make sure that you guys are comfortable with everything that you need to know for area. So all of our area basics, and then also discuss circles in a little bit more depth. We're going to be discussing two things today with regards to circles. We want to take a look at how we calculate the area of circles as well as the perimeter. And that might seem quite simple, but it gets applied a lot in the world of volume and surface area. So we want to make sure that we go through that. And then lastly, guys, I just want to touch on your circle geometry. Okay. We're not going to dive into examples of geometry today. I want us to discuss all of the names and aspects of a circle. And although that might sound very simple, I think that there's a lot of students that have no idea what secants are or what major arcs are, and so on and so forth. And this has all got to do with our circles. So what I'm going to do is start by sharing my screen with you guys, and then we're going to get going with today's work. Now, if you have any specific questions about circles, right, whether we're talking about um, area and perimeter for circles, questions about pi, and so on and so forth, now is a good time to ask, guys, so that I can answer them as I go through the lesson. All right. So we're going to dive straight into today's work. Um, just give me a second to start sharing my screen. Sorry, guys. Do we have any questions so far about circles or from anything that we discussed last week, grade nines? Please understand that if you guys intend on taking maths core next year, a lot of you will begin discussing a lot of circle geometry. And so it's really important that you know all of the different aspects of a circle as well. Okay. If you have any questions, guys, please ask. I have my eye on all of the comment boxes. So I am waiting on your guys' messages. Okay. Right, so you guys should be able to see my screen now, grade nines. I hope that you guys can see everything clearly. If you can't, please let me know. You should be able to see me scribbling in white, yellow, orange, and green pen. All right, if that changes, please let me know so that I can fix the problem. All right, so let's quickly just dive into discussing the fundamentals of today's work, guys. I think it's important for you guys to keep in mind that when it comes to questions about area and volume and so on and so forth, a lot of the time you're not simply just going to be asked, what is the volume of this shape, right? A lot of the time your teacher will put information into a question, right? And we'll look at these word problems and then have to do two things. Not only do we have to derive information from the question itself, we also then need to be able to understand how to work with that information. Okay, so the date for today is the 29th of April. Our heading is going to be area formulae and circles. Okay, right. So, guys, um, let's get going with just talking about our basic area formulae. You guys know that when we're talking about the area of a square or the area of a rectangle, we know that we have to use length times width. That's no surprise. Then, when we talk about the area of triangles, you guys also need to please keep in mind that we use perpendicular height, not slanted height. So a half times base times perpendicular height. Okay. Number three, you guys need to be familiar with the formula that we use for the area of a trapezium or a trapezoid. Okay. Now, this isn't one that's always given by teachers. Sometimes you guys will have to um, calculate it without the use of the formula by breaking the shape down, right? You need to treat it as a compound shape, but we're going to take just a look at one of each of these shapes and then move on. Okay, so the area of a trapezoid is calculated using the formula that I put below. Okay, then the area of a parallelogram is another important shape. Uh, and guys, we might actually shift gears, come to think of it, I might choose to discuss the properties of these different shapes with you because that's also going to be really important. Okay, guys, somebody has said that the screen is blurring a little bit. I'm not sure if that's happening for everybody, but please keep in mind that the clarity of my image is often going to depend a lot on your internet stability. Okay. So give it a second. If more of you are struggling with that, please let me know. The area of a parallelogram, guys, is simply base times the height of the parallelogram. But there are more ways that we can go about calculating the area of these shapes. Now, when it comes to the area of circles, guys, let's quickly take a second to discuss this because this confuses a lot of people. If I am given a shape, a circle, and a lot of the time will be given the radius, if not the diameter. Let's say our radius is 4 millimeters or just 4 meters. Simply. You guys by now should have memorized the formula for the area of a full circle, right? We know that the area of a full circle is pi r squared. Okay. Now, if I decide that I need to calculate the area of half a circle, everybody tends to get a little bit confused at this point, guys. But if I know that the area for a full circle is pi r squared, it should come as no surprise that we can simply multiply this entire expression by a half. That is the formula we use to calculate the area of a half circle. And lastly, we also need to know about the area for a quarter circle because these are the most commonly used pieces of a circle. a full, a half, or a quarter. So if I want the area of a quarter of a circle, it would simply be a quarter pi r squared. Okay, let's say I wanted an eighth of a circle, right? I wanted 1/8 of a circle. I could literally multiply pi r squared by the fraction of the circle that I am looking for. So please just keep that in mind. Okay, that's really important. Okay, so we have all of these different area formulae, and you guys have really got to practice using them as much as you can, right? Because they are going to be given to you in all sorts of questions. Right. Now, um, a lot of students are still very confused about where the concept of pi comes from. So, I want to discuss this very quickly, right? Because circles are going to be a relatively big part of today's discussion. So, let's talk a little bit about circles very quickly. Why have I written down all of these area formulae, grade nines? Because you guys need to know all of them. Okay, if you choose not to memorize, for example, these two formulae over here, you then need to know how to calculate the area of a trapezium and a parallelogram without using these two. Okay, but these are the shapes that we see come up a lot in different questions regarding our um, measurement calculations, right? Now, when we think about circles, the first thing to come to mind is this concept of pi, right? Now we know that this is a constant, 3,14159, and we know that it's non-terminating. In other words, it's a decimal that never ends. But what exactly is pi? I'm going to touch on this once very quickly. Pi is the ratio between the circumference and the diameter of the circle. Pi is C over D. Why is this important? Grade nines, it's very possible that your teacher could give you a circle in a test, right? And in this question, your teacher will say to you that your circle over here has a radius of length x centimeters, x centimeters. But they tell you that the circumference of the circle is, uh, let's say, 100 centimeters long, just as an example. Right? We know the length of the outline of the circle, the circumference going all the way around. If your teacher gives you this information and then asks you to calculate the area of this circle, how are you going to go about doing that? Well, first things first, you need to be aware of this formula over here. Pi is a constant, grade nines, which means that it's a number that is never going to change. Pi is always going to have the same value. Where does this number, constant pi, come from? Well, if we take any circles, let's say we took 5 different circles, we measured the circumference of the circle and we measured the diameter of the circle in the same units, right? So both are in centimeters, both are in meters, or whatever the case might be. When we put them into a ratio like this, the answer is always going to be pi. What is that trying to tell us? It means that as the diameter of my circle grows, I circumference of my circle is going to grow at the same rate. So they always stay in proportion with one another. So let us say, for example, uh, we have three different circles. Circle number one has a circumference of, um, sorry guys, just give me a second. 12.566 centimeters. What is the diameter going to be? Number two, let's say we have a circumference of 47,124 centimeters. Again, calculate the diameter. I would like for you to try these on your own, grade 9s. Question 1, question 2, and question 3. How are you going to find the answer? You are going to use this formula that we see at the top of the screen over here. Right. You must be able to calculate the value of the diameter in the circle. For question number 3, calculate the area of the circle. Right, I'm going to give you guys 3 or 4 minutes to quickly try these on your own. You need to find the diameter of the circle. In the case of question number 3, you're given the circumference of 235.620 centimeters. You need to calculate the area of the circle. Please go ahead and try this on your own very quickly, grade 9s. I'm going to give you 3 minutes to find your answers, and then I'm going to do it with you on the screen over here. Remember, you are using the formula that you see at the top of the screen. This is not only testing your understanding of this formula and circles, but also substitution. If you guys have questions, please ask. See if you can find the correct values, grade 9s. In the case of question 3, I want you to think about this circle over here. You can use this as a diagram to help you answer question 3. got 1 minute left. Then I'm going to go through this with you guys. All right. When we try and approach these questions, grade nines, let's think about the formula that we've been given. We've been given pi is equal to the ratio of the circumference to the diameter. We can change this formula to suit us in answering these questions. If we multiply both sides by the value d, we begin rearranging our formula. And we want to get the diameter on its own. So if we divide by pi on both sides, the diameter of a circle is equal to the circumference of that circle divided by pi, which is a constant value, right? That's the first thing I want you guys to just keep in mind. So I'm going to write or just move this over here to the top of the screen. And if we attempt question number one very quickly using this formula, the diameter of circle number one is the circumference divided by pi. In this case, the circumference of our circle is 12.566. Now, for those of you that might be curious about this, pi does not have a unit. It is a dimensionless constant. So it doesn't matter if my diameter is measured in meters, centimeters, meters, or kilometers. It does not matter because pi is not related to a specific unit. So we're going to have this divided by the value of pi. Now, for a lot of you guys, if you have one of these silver calculators, maybe the black version, it's okay. If you have a scientific calculator, you should be able to find pi as a value instead of having to manually type out 3,14159 and so on and so forth. Okay, so if we take 12.566 divided by pi, you'll see that the answer can be rounded up to 4.0 centimeters, essentially, right? Rounding to 2 or to 3 decimal places. The same applies for question number two. Looking at the diameter, when we are looking for the diameter, we can take the circumference of the circle divided by pi. We were given the circumference. It's a value of 47,124 centimeters. Again, the centimeters do not matter because pi is unitless. Okay. Again, you can put this into your calculator manually. 47.124 over pi gives us a value rounded to 2 decimal places of 15.0 centimeters. Right? Now, just on a side note, very quickly, if we know that the diameter of the circle is 4 centimeters, this means that you are allowed to infer or conclude that the radius is 2 centimeters for the circle and 7.5 centimeters for the second circle, right? So that's going to be your hint when it comes to trying to solve question number three. R is 7.5 centimeters for circle number two. So if we repeat the process one last time For diameter number 3, again, we are working with the circumference divided by pi. In this case, our circumference is 235.620 centimeters divided by pi. And when we input this value into our calculators, you'll see that the answer comes back rounded to two or to three, sorry guys, to two or to three decimal places at 75.0 centimeters. So you can make the inference that 75 over 2 is the same as 37.5 centimeters for the radius of this circle. Now, if we pay attention to um, the diagram that I drew over here at the bottom of the screen, we know that the circumference of this circle is 235.620 centimeters. Because of that, we were able to find the diameter as 75 centimeters, and we know that half of the diameter is equal to the radius. That's why I've halved all of the values to find r. So what does that tell me? Instead of having x over here in my circle, I now know that the value for x, in this case for the radius of my circle, is 37.5 centimeters, right? So to complete question 3, we need to be able to say that the area of a circle is equal to pi r squared. And in this case, we know that r has a value of 37.5 being measured in centimeters. So you can again put this straight into your calculator, but please just be careful with your exponents. Now, you are allowed to write, for example, 5,625 quarter pi, right? This is the answer that your calculator gives you first. But your tests are very likely going to ask you to convert everything to two decimal places because that's what we do in measurement. So we'll find that the area of this circle is 4,417.86 square centimeters. Don't forget your units. Okay, so that is how we are able to find the area of a circle when we are only given the circumference. These are the sorts of tips that you need to be aware of when going into your exams, guys, because sometimes your teachers are going to test your really detailed understanding of a topic. Okay, so I hope that this makes sense. I'll give you guys a second to copy. If we have any questions, please quickly ask me now. Okay. Now, let's say we took this a step further, guys. I'm going to quickly type a question out here. Okay, so just bear with me for a second, please, guys. Sorry, guys, just a second. I just want to quickly type out a question for you because I want us to be able to also apply this understanding to um, word problems. All right. So a water trough has a diameter of 60 centimeters. A farmer wanted to paint the outside of the trough. How much paint would they need in square centimeters? That's our first question. Secondly, if the farmer wanted to fill the trough with water, how many milliliters of water would they need? Okay, this is a question that I want us to go through. If you guys would like to quickly get down, you're more than welcome to. This question is testing your understanding of surface area, but also volume of circles, essentially parts of a cylinder. Okay, so a water trough has a diameter of 60 centimeters and is 150 centimeters in length. If a farmer wanted to paint the outside of the trough, how much paint would they need in square centimeters? And secondly, if the farmer wanted to fill the trough with water, how many milliliters of water would they need? Now, there's a lot going on in this question already, but there's a lot that I'm going to quickly explain to you guys. What is a water trough? A trough is one of these cylindrical or semi-cylindrical shapes you see that is full of water, and it's what a lot of your herded animals will drink out of, right? Your horses, camels, sheep, and so on can drink out of these, and they're essentially half of a cylinder. So think about taking a long cylinder and slicing it in half lengthways, right? So all of this over here gets filled with water, and that's what the animals are going to drink out of. So we are working with a very interesting shape here. Now, I would recommend that you guys take time to uh, draw a shape for yourself. It doesn't have to be perfect, guys. It really doesn't, but it's just for your reference and your understanding. Okay. Right. This is not a perfect diagram, but it looks something like this. Okay. These are the troughs that animals will drink out of. Now, we know that this trough has a length of 60 centimeters, or sorry, 150 centimeters, and its full diameter is going to be 150 centimeters, sorry, 60 centimeters. So if we're given these measurements, how do we go about calculating the values that they have requested? If a farmer wanted to paint the outside of the trough, how much paint would they need in square centimeters? So if we think of this as almost like a water bottle cut in half, right? It's half of a cylinder. How do I calculate the space on the outside of this shape? We know that we would have to be working with the surface area of the shape, right? Now, what is the surface area of this piece of a cylinder going to be made up of? We're going to have this front plate over here and the back plate over here. Then we're also going to have this rounded edge that goes all the way around the base, right? That holds the water. So how are we going to figure out the surface area of this shape? We know that this front and back piece over here are going to be the same in size, right? And they're going to be half a circle. How do we find the area of half a circle? We use a half times pi r squared. So if half pi r squared is for one of the semicircles that we see on the side, we then need a second half pi r squared, right? Now, if I take a piece of paper and I fold it very quickly into a rough circle, I know that I'm looking at something like this, but it needs to be cut in half, right? I have the bottom half of this cylinder. It's like cutting a barrel completely in half. If I need the surface area of the underside over here of my circle, how am I going to find that? I'm going to need to use the area of a circle, sorry, the circumference of a circle. If I think of a full circle, guys, how do I calculate the full circumference? Well, the circumference is equal to the perimeter of the circle. And we know that this is equal to 2 pi r. But remember, I only want half of a circle where the water is going to be sitting, right? I don't have a full circle. So how do I find the perimeter of half a circle? Well, the perimeter is then half times all of this. A half times 2 pi r. And if we simplify this, guys, the half and the 2 are going to cancel. So the perimeter of half a circle is simply pi r, right? We know that this section over here of our trough, this line over here, is equal to pi r. So if we take that and we multiply it by the length of my trough, I will be able to find the full surface area of the bottom of my trough. So adding on to my calculation over here, we have pi r times the length. Okay. This is where your understanding of the formulas is going to come into play, guys. This is why I've put so much emphasis on circles today. Okay. If you guys need to copy this, I'm going to give you a second to do so before we start solving the question itself. Okay. Please ask me if you have any questions. All right. So now that you guys have just had a short second to copy, we know where this pi r l comes from, right? It comes from our calculation where we wanted to find the surface area of the bottom half of a cylinder. So if we now have a formula that we've created, we need to start substituting values. Let's go ahead and do this. Half times pi r squared. What is the value of r? If we know that the diameter is 60 centimeters, half of that is going to give us our radius. So our radius is 30 centimeters. That means that in the place of r, we can put the value 30. And finally, in this last section over here, pi r times L. Again, the value r is 30, but the length is 150. Right? We get this information from the question. The hard part is sitting and deriving our formula that we are going to use, because we do not have time to memorize the formula for the surface area and volume of half of a cylinder. So we've got to learn to practice taking a formula and manipulating it so that you can get a fraction of a certain shape. Right. Now, again, I think it's a good idea for us to write some values in terms of pi before we get the converted value. So when we put these into our calculator, we get 450 pi plus 450 pi plus 4,500 pi. Again, once all of these are added together, we get 5,400 pi. And the reason why I recommend leaving it in this form, guys, is so that you can refer back to it easily. If you round off your answer over here, but for some reason you need the full value in another calculation, you can come back and look at the value before your final step. Right? 5,400 pi translates to 16,964.60 square centimeters. So he basically has to cover 17,000 square centimeters worth of area if he wants to paint the outside of this trough. Okay. This is how you are going to be asked about the measurement calculations regarding different shapes, grade nines. Right. Then, question 2 says we're still working with the same shape, half of a cylinder cut lengthways. If the farmer wanted to fill the trough with water, how many milliliters would they need? Now, you guys might look at this and freak out, and I completely understand why. How in the world are we going to find the number of milliliters? Okay, now, if we're thinking about filling something with a liquid, grade nines, it means that we are thinking about volume, right? We are thinking about volume. So if I'm thinking in the context of volume, it means that I'm looking for half the volume of a cylinder, right? This is simply half a cylinder. And it asked if you wanted to fill the trough, not partially fill, right? Completely fill up the trough. How many milliliters of water would they need? Now, the section over here about milliliters we'll get back to, but we know that when we fill something with a fluid or try and calculate how much space something is going to take up, we are talking about volume. How do we calculate the volume of a full cylinder, guys? Let's say I had a full cylinder over here. You guys are more than welcome to draw circles and little diagrams in your test. If I'm thinking about the volume of a full cylinder, I know that I need to consider my base shape first. And we chatted about this last week. If I imagine this as a tall cylinder, like a Pringles can, if I can find the area of the circle, pi r squared, and I multiply this by the length of my cylinder, it's as though I take these circles and I stack many circles on top of one another to help me find the full volume. So you guys can choose to practice deriving the formula for the volume of a cylinder, or you may memorize the formula on your own. The volume of a cylinder is going to be pi r squared times length in this case, but generally it is times height. Now, what's the problem with this in the context of our question? We do not want the volume of a full cylinder. We want the volume of half of a cylinder, right? So just keep in mind, guys, the official volume formula is going to come with a height inside of it, right? But in this case, we're just talking about length because we have a cylinder laid on its side. It's not vertical. Because we want half of a cylinder, we can quite literally half the area of a full, oh, sorry, the volume of a full cylinder. So there we go. This is how we are going to calculate the volume of a half cylinder. Now, you guys can clearly see that when it comes to these questions, the most tricky aspect is number one, deriving the information from the question. And that's why I'm saying that um, using diagrams is going to help you a lot, right? It helps you to visualize the information that you've been given. But the second most complicated part is just trying to find the correct formula to use, right? Your teachers are not going to give you everything on a golden platter. So they're going to give you the formula, for example, for the full volume of a cylinder, but then maybe they'll test you on half a cylinder. And you need to have worked with these formulae enough to be able to say, okay, I simply need to half the full volume of the cylinder to get the volume of this trough shape that we are talking about. So if we go ahead and substitute, we're going to have a half times pi, and again, our radius is still 30. But now we need to multiply by the length of my shape, which we have at the top right over here, right? It is 150 centimeters long. So we are going to place this into our calculation and then put all of this into our calculator. And it gives us an answer of 67,500 pi, which again, I would recommend you writing down. And when we convert this using the S to D button on our calculator, and we round to 2 decimal places, we get the following answer. But this is measured in cubic centimeters. 212,000 cubic centimeters. Now, I'm going to give you guys just a small hint. It's something that you will hopefully write down and take forward with you because it's very possible that you could get a question like this at some point. 1 cubic centimeter is equal to 1 milliliter of fluid. So when the question asked us about milliliters, a lot of you would have gotten very nervous, but it's helpful to keep in mind that a cubic centimeter, right? Whenever we write these answers for volume in cubic centimeters, we can write it just as easily in milliliters. So taking this answer, we can simply write it as 212,057.50 milliliters. And that is the final answer for today's question, guys. Okay. I hope that that makes some sense to you guys. Now, just on a side note, something that's very helpful to do when we attempt questions like this is to try and fact check ourselves with basic logic. So, if I think about a trough, right? It's like a can that's been cut in half and laid on its side. If this trough is 2 rulers wide, right? And it's 5 rulers long, how much water do I think I would have to put into that? Well, I know the question doesn't ask for it, but to sort of try and check my own understanding or fact check my answer, maybe I have time left over at the end of an assignment or a test. If I take this number, I'm working in milliliters. We know that there are 1,000 milliliters in every liter. So if I take my final answer over here and just for my own sake go and divide it by 1,000 so that the number is a little bit more readable, it means that I actually have 212 0.10 liters. So looking at a trough like this that animals are going to drink out of, does it make sense that I would put 200 liters in there? And yes, guys, that does make a fair amount of sense. Okay. 212 liters is not actually that much. So that's just a way for us to double check our work, um, keeping in mind what we know about our unit conversions. All right. I'm going to give you guys a chance to copy, but guys, that is most of today's lesson done. We've only got about 5 minutes left, and it doesn't appear to be likely that we'll have time for more examples. But what was the purpose for today's lesson? I want you guys to keep in mind that when we go through a question like this, when there's a word problem with measurements, there are a few steps that we want to follow, right? We want to first start by understanding the information that we're given. Number two, maybe we want to use diagrams and pictures to help us visualize what's going on. When you are sitting in a test scenario and you're very stressed, it's very easy for your brain to make silly mistakes. Step number three in these sorts of questions, you need to slowly but surely begin by deriving a formula for yourself, right? You need to know exactly what it is that you want to calculate. And after this, guys, substitution and solving, the last step is very easy, right? That's the part that takes the least effort or thinking because we're plugging things into our calculator and just keeping a specific unit in mind for our answer. So when you run into questions like this in a test or an exam setting, maybe you guys are getting really nervous, right? And these sort of questions really tend to bother you. That's okay. I want you guys to start by really trying to use pictures if you can, right? Um, You're going to have to take the question step by step, and I'll give you a piece of advice now already for the rest of grade 9 and the rest of high school. Teachers are going to try and give you a long paragraph of information and shove lots of different numbers and words in there. And you've got to practice sorting out the numbers and the words, right? If you can't do that, you don't know how to solve the question. So, what was today's lesson for in the end? I wanted to show you guys that while, yes, measurement seems like a simple topic, it's not quite as simple as you think in test or exam scenarios. You guys can practice using your textbooks, iRainbow, and past papers as well to practice going through these questions in exams. Print out a few exam papers and sit and highlight all the information and try and draw a picture first, right? If you cannot draw a picture that contains all the information you need, it means there's something you're not quite understanding. Okay. So you want to put as much information into these pictures as possible, because then when you refer to it during your calculation, it gives you one image to look at that sums up all of the information instead of having to go back through a question multiple times over, rereading the information, and possibly confusing or even just stressing yourself out. Okay, so guys, uh, I unfortunately am unable to stream iRainbow for today. I do apologize for that. But if you want to practice work like this, you can obviously use your textbook, but I would suggest also taking a look at iRainbow. If you go to iRainbow and you click on the very first or the topic of measurement, under this you will find perimeter, area, volume, and surface area, right? And you guys need to be able to go through all these quizzes and achieve really high marks. If you can do that, it means that you're in a really good space, right? You understand the basics thoroughly. So I would strongly recommend you guys go and use iRainbow. Go to these sections on the platform and test yourself. Okay. Go and do all of the quizzes on perimeter. You might think, oh, but sir, perimeter is so easy. That's like grade 7 work, maybe earlier. Well, when it comes to calculating the surface area, the bottom of one of these half cylinders, do you remember, or do you know, and you can recall the fact that this part of a circle has a length of pi r? If not, then going back to doing perimeter of circles specifically may not be all that bad of an idea. Okay, guys, without understanding the basics, the more complicated formulas just make no sense. All right. So please go and spend some time practicing the quizzes on iRainbow, guys. Um, go through all the basics. Even if you think you know it, try the quizzes and see what you get as results. Remember, I've shown you guys before that there is a tab for reports. And under that, you can go and look at the mark that you got for each of the quizzes. If you get anything below 80% for all of these quizzes, it means that there is some stuff that you still need to go back and practice. So maybe use this as a benchmark. If 80% is too high, start with 60%. Okay. But go and test yourself, see where you might be having a little bit more trouble than you thought. Practice it. Okay. And go through these questions like the one that we've written down today. Although this seems like such a simple question, right? If we go through the information, the word trough, sorry, I spelled that incorrectly, guys, not trough. Um, Trough is important. Diameter is important. 60 centimeters, 150, and length are all important, right? Painting the outside of the trough, how much paint do they need in square centimeters? If you can't recognize that that's surface area, then maybe just go over the concept of surface area and revise, right? Filling a trough with water should indicate that you are working with volume. And then milliliters is something else to pay attention to. So already in this question, you've got 7 or 8 pieces of information that you've got to be able to pull out and hopefully organize into a diagram like this. Okay. Please remember, it is going to take time, and you do have to find your own style of doing it. If my pictures make no sense to you, take 10 minutes after this lesson to try and draw your own picture, right? Fill your own information into the picture and see if that helps you to understand what's going on. Maybe try and derive these formulas on your own, because this is a skill that we're going to have to develop as we go up in high school. Okay. So, grade nines, that's going to be it for today, guys. I know that there was a lot of information, but I hope that a lot of it was good and that you guys benefited from the information in some other way. I haven't seen questions for most of this lesson, so I'm going to assume that you guys either understood everything or you already knew it. Um, but I'm going to stick around for one more minute quickly if you guys have any questions about this for me. Okay. Type your question into the comment box and then I will read it and answer it. But if you guys are happy and you understand everything that I've discussed today, that's it for today's lesson, guys. I appreciate you attending. I hope that you will try and maybe take the steps that I have written down here into consideration, because you guys are going to need to develop your own style of approaching things in tests or exams. Okay, so there's no harm in experimenting with different methods for now. Okay, that's it. Our next lesson is going to be next week, Wednesday, between 5 and 6 o'clock. Once again, a message will be put on the group to share the times with you as per usual. So please keep an eye out for that. If you guys have specific topics that you would like for us to approach now entering the exam season or the exam prep season, please type a message into the comment box saying, "Sir, please can we go over this part of algebra, or can we please go over this specific aspect of geometry?" Okay, I'll try and take those comments into account and then see if we can work them into our upcoming lessons. Um, but guys, please also just keep in mind that the recording for today's lesson will be available on both Facebook and on YouTube, so you can go watch the recording if you need to come back and take notes or just go through it a little bit more slowly. It's up to you guys. It's free to access, so please make use of it and go and practice on iRainbow. All right. Thank you so much, grade nines. We're done for today. So if you guys are happy, you're more than welcome to leave. If you have any questions, I'm here for one more minute, so please ask away quickly. Otherwise, we will have to speak again next week, Tuesday. All right. Thank you so much, guys. Have a fantastic week ahead, guys. Do we have any questions, grade nines? You've got 1 minute to quickly ask away. If not, guys, then if you think of any questions during the week, you're more than welcome to write them down and bring them to our next lesson. And once again, I unfortunately can't repeat this all too much, but if there is a specific topic that you want us to go through in the coming weeks before your exams, please type a message into the comment box for me, okay? It's a way for me to keep track of what you guys would like to go through. Okay, guys, I'll keep an eye out for any messages over the coming days, and I will chat to you all again next week, Tuesday. Please remember we have a lesson at 5 o'clock to 6 o'clock in the afternoon. But until then, guys, have a fantastic time. I'll chat to you all then. All right. Thank you, guys.